What's up guys, welcome back to the channel. Today on this video we'll be solving this previous question paper that you see here. As you can see, this is a national certificate for mathematics N4, and this question paper was actually written on the 27th March 2025 X paper, and also it took 3 hours. So on this video we're gonna only focus on question 2. So before we solve the problems on this question 2, I'd just like to say thank you very much guys for watching, subscribing to the channel, commenting, and not forgetting those who like and share the videos. If you haven't subscribed to the channel, subscribe to the channel because I've made lots and lots of videos based on previous question papers similar to this one and more questions on mathematics. Again guys, you can now support our channel by clicking or hitting the super like button where you can donate some funds to support the channel so that we can give you the best content with a higher quality. All right guys, so let's go back to the question paper. I would like to inform you guys, if you haven't watched question 1 of this question paper, you can go to the description. I will leave a link of that question so that you can go and watch it, and the very same video will pop up on the top right of this one that you're watching here. And also I'm going to leave the timestamp so that you can able to watch any question that you desire if you are not willing to watch this video in a sequence order. All right guys, so let's go and check question 2 and let's solve it. Right, question 2. As you can see, question 2 consists of determinants and also complex numbers. So we're going to start with 2.1. We're going to copy this question, paste it where there is space, and then let's solve it. Right, question 2.1. As you can see, we have this problem here. We are given 3 equations that you see here, and then they say we must use Cramer's rule to calculate the value of z. Now, this one here, guys, are determinants. So first of all, we need to create the square matrix. So we need to take only the coefficient of x, y, and z. As you can see, the first column is the coefficient x, the second column is the coefficient of y, the third column is the coefficient of z. So let's create the square matrix. Right, so we have the first column, which is going to be 5, 2, and 3. These are the coefficient of x's. And then the second column, which is going to be the coefficient of y, we have -6 for the first equation. For the second equation, we have -3. And for the third equation, we have 7. And then for the last column, we take the coefficient of z. We have 3 for the first equation. We have 2 for the second equation. We have 5. Then from here, we have our square matrix. Guys, just in case you didn't know, this is a 3 by 3 order or matrix. So just in case you didn't know, this is 3 by 3. All right, so we've created our square matrix here. So it's time for us to calculate the determinant. But before we calculate the determinant, you need to know about cofactors. Right, the set of signs that are placed based on the entries here. On the first entry, we want to have positive. The second entry, we want to have negative. And then the third entry, we want to have positive. So actually, the signs, they alternate. So for the second row, the first entry is going to be negative, second entry is positive, third entry is negative. And then the last row is going to be positive, negative, and positive. So this here, guys, is what you call cofactors. So we're going to use them a lot when we calculate the determinant. Right, so another extra information that you need to know before you calculate the determinant, you need to select your minus. So it's up to you guys. You can select any row and any column. So I prefer to select the first row so that we can use these numbers or these entries on the first rows as minus. Right, now that we have managed to select our minus and we managed to establish our cofactors, we can start calculating the determinant. Now, when you calculate the determinant on the 3 by 3 matrix, you need to select a minor. After selecting a minor, use that minor to cancel the row and the column. If we say minor is 5, meaning this 5 here, we're gonna first cancel the column at which 5 is at, and also we're gonna cancel the row where 5 is. So from here we can start calculating. So we know that when the minor is 5, our determinant we're going to first multiply by this minor. What is it that we are left with there? We're left with negative 3, 2, negative 7, 5. There we go. Right. Now, on the next one, when the minor is negative 6, remember, we are moving with this first row here. So we need to cancel the column as well. So when you cancel the column there, we'll be left with 2, 2, 3, and 5. But let's not forget the cofactor. So when we move to the second minor, the cofactor here is supposed to be negative. But the minor, which is negative 6, is also going to be multiplying there, negative 6. And then multiply by our matrix that is left there, which is 2, 2, 3, 5. There we go. Now, when the minor is 3, now this 3 here, so we have to move this, crash the last column and the row that 3 is part of. So when you look at our cofactor, when you go to the third minor, this is going to be positive, and 3 is also positive. So even if we write positive 3 there, it's all good. Then what is it that we left with there? We left with 2 minus 3, 3 minus 7. There we go. So this is a step that you need to know when you calculate the determinant when you are given the third order. Right, so let's continue. Just in case you don't know, guys, how to calculate the determinant, I've made a video, so you can go to that video on the description, click on that link, and also the very same video will pop up on the top right of this video. So what I'm about to do here is part of the video there. So just in case you don't understand, go to that video, click it to learn further. So when you calculate the determinant, we usually do the following. It's going to be 5 multiplied by, now you multiply the first entry, which is negative 3, with the last entry here, which is 5. So it's going to be negative 3 multiplied by 5. There we go. And then this product here is going to be subtracted by the product of the second entry and the third entry, which is going to be 2 multiplied by negative 7. There we go. Then we close the bracket. Minus minus on the second minor is going to be 6. There we go. And then we do the multiplication. Again here, guys, we do similar thing. The first entry, which is 2, is going to be multiplied by the fourth entry, which is going to be 5. And then the product of these two entries is going to be subtracted by the product of 2 and 3, which is the second entry and the third entry. There we go. Then we close. And then the last minor, which is going to be 3, also we're going to calculate here. We're going to multiply the second entry with the last entry, which is 2 multiplied by negative 7. And then minus. Always the minus, guys. The product of the second entry, which is 3, and the third entry, which is also 3. So the second entry is negative and the third entry is 3. So they multiply each other. So if you continue here, let me try to continue here on top here. We know that determinant is going to give us negative 5, right? Plus. And then the second minor is going to give us 24. And then the third minor, which is 3, is going to give us negative 15. So if you continue here, our determinant is going to be 4. There we go. So our determinant for this matrix is going to give us 4. Right. So now that we managed to calculate the determinant, it's time for us to calculate the determinant for Z. Right. So let's recreate the square matrix again when we calculate for dz. When we calculate for dz, we need to recreate our square matrix, but this time around we'll have to take the constants values and substitute with the coefficient of z. Basically what I mean is the first column, which is 5, 2, 3, is going to remain like that. The second column, which is negative 6, negative 3, and negative 7, is also going to remain like this. But the third column, because the third column consists of z coefficient, we're going to substitute those coefficients with our constant, which is going to be negative 9 for the first equation, negative 5 for the second equation, and negative 16 for the third equation. So this here becomes our square matrix for dz, or the determinant for z. Again, you need to select the minor here. So I prefer to continue select my first row as the minor, but you can choose any row, any column. It's easier when you choose the first row as your minor. Right, so let's continue. Now, when you continue, we need to calculate for dz. So we're going to do similar with what we did with determinant. So when the minor is 5, we're going to do the very same thing. We're going to scratch the column and the row where 5 is. So let's start with the row. There we go. And then we go with column. There we go. So we're going to be left with -3, -5, and -7, 16. So we're going to say the minor is 5, but what is left here is -3, -5, -7, and -16. So this become our square matrix for 2 by 2. Then when the minor is -6, now let us not forget the cofactor is negative and our minor is negative. This becomes +6. So I'm just going to skip some of the things there. Right, we have to move this to the column in the middle. Now we are scratching the column in the middle, which is for -6, and the row, which is for -6. So we'll be left with 2, 3, -5, -16. There we go. So this is going to be our square matrix when our minor is 6. Now let's create more space so that we can have the minor of 9. Right. So this time around, we have to say when the minor is -9. Remember, we're still going to take from the first row. So we're just going to move this one here. There we go. Remember the cofactor. Let's go back to the cofactor. Our cofactor for the third entry is going to be positive and our 9 is negative. So meaning here we will be having -9. We'll be left with 2, -3, 3, -7. So this is our matrix then. Right, so let's continue. Let me continue here on top. dz is going to be, now for our first minor is going to be 5 multiplied by, let's open our bracket. We have the first entry, which is -3, multiplied by the last entry, which is 16. Then this subtracted by our second entry, which is -5, multiplied by -7. There we go. So this is when the minor is 5. But what about when the minor is 6? Remember, we have +6 here. Let's create more space again. We're going to multiply the first entry with the last entry. Is going to be 2 multiplied by -16 minus, what is our second entry? Is going to be -5 multiplied by 3. There we go. So this is for the second minor when minor is -6. And then last we have -9. It's time for us to create more space again. So when you calculate the determinant, we're going to multiply by the first entry, which is going to be 2 multiplied by -7 minus -3 multiplied by 3. There we go. Then from here, we use our calculators. For the first minor, when it's 5, we have 65. The second minor, where we have -6, our answer is going to be -102. And then the last minor, where we have -9, we're going to have +45. Then when you add these together, they're going to give you 8. So our dz is going to be 8. So remember, when we are calculating for z, the formula goes like this, is dz divided by the determinant. So this determinant that we got here, which is going to be 8, is going to be divided by our determinant that we got earlier, which was 4. So our final answer, z is equaling to 2. All right, this was a bit long. I hope you managed to follow through and understand. I tried my best to explain the best that I can, but just in case you didn't understand some of the things, especially the basics on how to calculate the determinant, there is a video on the description. Go and watch that video. It explains better how to calculate the determinant. If it so happened that you didn't understand, you can also rewatch the video at the point where you got lost. And if that doesn't help, you can also leave a comment in the comment section asking a question. I'll try to help you to my level best. But if this video helps you to understand, or this part of the video helped you to understand, do not forget to like and subscribe if you haven't subscribed. Again, guys, you can also support our channel with a super like. All right, guys, we are done with question 2.1. Let's go and do question 2.2. All right, we are done with 2.1. How about we look at 2.2? As you can see, here is our 2.2 here, guys. So I'm gonna copy this question, paste it where there is space, and then let's solve it. Here's our 2.2, guys. As you can see, we are given these two equations. So they want us to find or determine the value of x and y using the method of Cramer's rule. We have two equations, so this makes it to be 2 by 2 or second order matrix. So first of all, we need to rearrange this so that we can able to create the square matrix. So let's start with this first equation here. If we transpose this negative 6y to the other side, we'll be having 7x plus positive 6y is equaling to negative 27. Remember, this is just rearranging, guys. Just make sure that the first term is contain x, the second term contains y. And then the second equation, we just have to transpose this 5 to the other side. So we're going to be left with 3x plus 4y. All this is equaling to 5. So there's two equations. We can also take their coefficient and create the square matrix. So let's do it. Let me start putting D there. If we take the x coefficient from the first equation, it's going to be 7, which represents the first entry. And then the second entry is going to be the coefficient of y, which is 6. The third entry is going to be the coefficient of x on the second equation. The fourth entry is going to be coefficient of y, which is from the second equation. So here we have the square matrix of 2 by 2. It's time for us to calculate the determinant. So for this one, guys, there's no need for us to find the cofactor and the minor. It's very simple, it's straightforward. So in order for you to calculate the determinant, you do the following. You multiply the first entry, which is 7, with the last entry, which is 4. And then the product of this will be subtracted by the product of the second entry multiplied by the third entry. There we go. So this here, guys, is going to give us 10. So our determinant here is going to be 10. Right. Now that we are done with finding the determinant, it's time for us to find the determinant for x. Now, when you find the determinant for x, guys, what you should do is, remember, the first column is for x. As you can see, we took the coefficient of x here. So since we are looking for determinant for x, we're going to substitute the entries on the first column or the coefficient of x's with the constant. For the first entry, it's going to be negative 27 since it's from the equation 1, and then the other one is going to be 5. There we go. These are constant, right? But since we are not looking for y, so the second column, we keep it as it is. We're going to write 6 here, we're going to write 4 there. Right, there we go. Now we do the very same thing that we did here. Dx is going to be equaling to, now you multiply the first entry with the last entry, which is going to be negative 27, multiplied by 4, minus second entry multiplied by the third entry is going to be 6 multiplied by 5, and all this is going to give us negative 138. There we go. Right, now that we find the dx, we can able to calculate x. So the formula, it goes like this: dx over d. There we go. So our dx is negative 138 divided by 10. So if we continue, this is going to give us negative 69 over 5. There we go. Right, it's time for us to calculate for y. So we need to find dy. So when we are calculating for dy, the first column, we're going to take our original entries here, which is 7 and 3, because now these are the coefficient of x. But as for the second column, where we have the coefficient of y, we're going to substitute them with the constant. So for the first equation, on the second entry, we're going to put negative 27. And then from the second equation, on the fourth entry, we're going to put the constant 5 there. And then we calculate for dy, or the determinant for y. So we're going to multiply the first entry with the last entry, and then subtract this product here with the second entry multiplied by the third entry. So if you continue here, put it in your calculator, this is going to give you 116. So if you're looking for y, the equation is going to be y divided by d, and then This is going to be 116 divided by 10. So our final answer here is going to be 58/5. There we go. So guys, this is how you calculate for x and y. Just in case you didn't understand how to do this, I've made a video where we have two equations similar to this one that you can calculate for x and y. So you can go to the description, click on that video, and the very same video is going to pop up on the top right of this one that you're watching here. It goes deeper into details on how to calculate for x and y. Just in case you didn't understand, you can go and rewatch at the point where you didn't understand. But if you did manage to understand, you can like the video and also share the videos. If you haven't subscribed, subscribe to the channel. Again, guys, if you want to support the channel to grow or to improve the quality of the content that we give you guys, you can also support our channel with the super like. But a like is enough if you can't do the super like. Right, guys, we are done with 2.2. How about you go and do 2.3? Right, let's look at 2.3. Now, as you can see, here's our 2.3 there. 2.3 consists of 2.3.1 and 2.3.2. So we're going to only take 2.3.1 and then paste it where there is space, and let's do it. All right, guys, let's look at 2.3.1. As you can see here, they want us to simplify the following. We are given these complex numbers here. They want us to change this into polar form. Now, as you can see, we have the exponent here. So this will require us to use the de Moivre's theorem. So you cannot use de Moivre's theorem when the complex number are in a rectangular form. We need to first convert this into a polar form, and then we can use the de Moivre's theorem. Now let's do it. Now, when we convert this to polar form, we first need to calculate the modulus. Now, the modulus is similar when you calculate your Pythagoras theorem. It's like when you're calculating your radius. So we know that the real number represents x, imaginary number represents y. Just in case you didn't know, sometimes we use j as imaginary number. So if you don't see I and you see j, this basically means this is an imaginary number. Now let's make m subject to the formula. We're going to have the following modulus. It's going to be x squared plus y squared, all this under the square root. Right, so let's substitute them. In this case now, what is our x? Our x is root 2 but squared, plus what is our y? Our y is negative 1 squared. There we go. So if you continue here, our modulus is going to be root 3. This is how you calculate the modulus. Now, you need to calculate the argument. The argument is basically the angle. So when you calculate the argument, you're going to use tan theta, which is equaling to y over x. There we go. Now, our argument is the angle. If we write theta is equaling to arc tan, our y, we know that is negative 1, and our x, we know that is root 2. So if you put this on your calculator, our answer here is going to be negative 35,264 degrees. Right, so this is our argument. So if we to rewrite the equation in a polar form, this is how we're going to write z is going to be equaling to our modulus, which is going to be root 3, right? And then polar, our angle is negative 35,264, all this to the power of 4. Right, so if you use the de Moivre's theorem, just in case you don't know much about de Moivre's theorem, I'm going to leave a video where I explain the de Moivre's theorem. Go and watch that video on the description, and also that video is going to pop up on the top right of this one here. If we use the de Moivre's theorem, you know that our modulus, which is root 3, is going to have the power of 4 there. And as for the angle, we know that this negative 35,264 is going to be multiplied by the exponent there. And if you continue here, this is going to give us z is equaling to 9 polar negative 141,056 degrees. Oh, this is how you calculate this type of a problem, guys. If it's given to you, you first change into polar form, which is what we did here, and then this is what we have inside there. and then from there you apply the de Moivre's theorem there, and then your final answer is gonna be this. Guys, I've made videos on this. You can go to the playlist and check the complex numbers where you will come across such a problem here. But if this video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. If you want to support the channel, do not forget to hit the super like button. But if you can't do that, a like is also appreciated, guys. Alright, guys, we are done with 2.3.1. How about you go and do 2.3.2? Right, guys, now that we're done with 2.3.1, how about we do this one, 2.3.2? I'm gonna copy it, paste it with the space, and let's solve it. Right, here's our 2.3.2. So they want us here to simplify the following complex number that we see here. So remember, guys, just in case you don't know, J also represents I. So J actually is imaginary number. In some of the questions we use J, in some of the questions we use I. So let's do it. Now, first of all, you need to know how to simplify your J's here. Before we continue, I need to inform you guys J squared is equaling to -1, or I squared is equaling to -1. Just in case you don't know much about this, you can go to the description. I left a video where I introduce this concept, or where I explain this concept. Go to that description, click on that link, and also the very same video is going to pop up on the top right of this one. Go and watch that video to understand this information further. Right, so we need to simplify this. So when you come across this, the first term on the numerator, we have j cubed. So you need to first separate this. You say j multiplied by j squared. This here is going to give you j cubed, right? Minus j squared. For now, let's leave it as j squared. This one, just simplify first. And then denominator, we have j squared plus 5j. And then we can say j squared squared. So if you multiply this j squared with squared, it's going to give you 4. Multiply by this j squared outside is going to give you 5. So this is how you separate them. The aim here is to simplify that we only have j squared, or j. So let's continue. If you look at the first term on the numerator, we know that j squared, or I squared, is equal to -1. So it's like -1 multiplied by j. This is going to be -j. There we go. Minus 1. Right, this j squared, divide by. Wherever there is j squared, we substitute with -1. So we have 2 multiplied by -1 plus 5j, and then we have -1 to the power of 2 there. If we continue here, let me try to continue here. We're going to have this +1 there, minus j, divide by, let's see at our denominator. The first term here, we're going to have -2, and this one here is going to be plus 5j. There we go. So when it's like this, guys, we have to simplify it further. We need to multiply by the conjugate. So the conjugate of the denominator, you only change the sign of the imaginary number. So you keep this -2 here, but this one becomes -5j, divided by -2 minus -5j. Just in case you don't know much about conjugate, I made a video where we divide complex numbers in a polar form. You can go to that video on the description, and also that video will pop up on the top right of this video. Right, let's continue. So now you start doing your FOIL. Let's do it here. So if you say 1 multiplied by -2, this is going to give us -2. 1 multiplied by -5j is going to give us -5j. Right, -j multiplied by -2, this is going to give us 2j. And then -j multiplied by -5j, this is going to give us +5j squared. All this is divided by the following. -2 multiplied by -2, this is going to give us +4. -2 multiplied by -5j, this is going to give us 10j. Right, 5j multiplied by -2, this is going to give us -10j. And then we have +5j multiplied by -5j is going to give us -25j squared. We're going to simplify here. Wherever there is j squared, we're going to substitute with -1. Again, whenever there is a like terms, they're going to subtract or add. So if we look at our numerator here, we have negative 5j and positive 2j. So first of all, we're just going to rewrite this number, the real number, and then negative 5j plus 2 is going to give us negative 3j, and then plus 5. Wherever there is j squared here, we substitute with negative 1, divide by 4. This positive 10j and negative 10j, they will cancel each other. You'll be left with negative 25. But instead of writing j squared, we're going to write negative 1. So we just simplify further. If you look at the numerator, we have negative 2 and we have 5 multiplied by negative 1. That will give us negative 5. This is going to give us negative 7. There we go. Minus 3j divide by. So when you look at our numbers here, we have 4 minus 25 multiplied by negative 1. So this is going to give us 29. So all in all, our answer is going to be negative 7 over 29 minus 3j over 29. So this here, guys, is how you solve or simplify the following problem here. Guys, I've made videos on this type of a problem. You can go to the playlist and check the complex numbers. You will come across a problem that has similar steps here or similar question. So I hope you guys managed to understand. If it so happen that you didn't understand, you can rewatch from the beginning. And also, if that doesn't help, you can leave a comment on the comment section. If this part of the video helped you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. You can also support the channel by hitting the super like button for us to give you a better and high quality content. All right, guys, we are done with 2.3.2. How about we do 2.4? Right, now that we are done with 2.3, let's look at 2.4 there. So we're going to copy this question, paste it with the space, and we want to try to calculate the following information that they are looking for. Right, let's look at 2.4. They want us to determine the argument and the modulus of the following complex numbers here. Guys, these complex numbers, before we start, they're in a polar form. If you see this with cis, basically this means that it's cos imaginary sign. So do not be confused. All right, if the complex numbers are in a polar form, they can divide and multiply each other. So here we don't need to change anything. All we need to do here is to multiply, divide these complex numbers in a polar form. Right, so let's start. So let's start with the numerator. When the complex numbers are in a polar form, the modulus, which is 2 and 3, they're going to multiply each other. So it's going to be 2 multiplied by 3 as for this one. Instead of writing cis, I'm going to write polar like this. Now, the argument, they're going to add each other. But since our 30 there is negative, this is going to turn out to be subtracting. Now, we divide. We do similar thing there. Remember, this is a polar form. The modulus on the denominator, they're also going to multiply. We have 4 multiplied by 5. And as for the argument, they're going to add each other. Since 21 is negative, so this is going to be 36 minus 21. Right, if you continue here, this is going to give us 6. That is going to give us 20. Right, and then our argument on the numerator is going to be 45. And then our argument on the denominator is going to be 15. There we go. So if you continue, the modulus, they're going to divide each other. So we can say 6 divided by 20. You don't really have to go further with this. And then as for the argument, the one on the numerator, which is 45, is going to be positive. The one on the denominator, which is 15, is going to subtract them. So if we continue with this question here, we can say that our final answer is going to be 3 over 10. And then our argument is going to be 30 degrees. So guys, this is basically what the answer is. So you can write modulus is 3 over 10, and then argument is 30 degrees. So this is how you do this one, guys. Just in case you don't know much on how to calculate the complex numbers when they are dividing and multiplying in a polar form, you can go to the description. I left a video where I explain this type of calculations, and also the very same video will pop up on the top right. It goes deeper and further with this type of calculations. Alright guys, but if this video or this part of the video helped you to understand how to solve this type of problem, do not forget to like, share, and also comment on the comment section. If you haven't subscribed to this channel, subscribe to the channel. And again guys, if you want to support our channel, you can hit the super like button there for a higher quality content. But if you can't, it's fine. Your like will be really appreciated. Guys, we are done with 2.4. We are going to do 2.5, the last question of this question 2. Right, we are done with 2.4. It's time for us to do 2.5 there, guys. So I'm going to copy this question, paste it where there is space, and let's solve it. Right, let's continue with 2.5. Now, this one, they want us to solve for x. We are given the equation here. We have 2x squared plus 4x plus 4 is equaling to 0. So they want us to solve for x here. What we need to do here is to take out the common factor or divide by the common factor here. So we can say we divide by 2 throughout like this. We know that we left with x squared plus 2x plus 2. All this is equaling to 0. Then it's time for you to find the factors. You can't find the factors, so you better use the quadratic formula. So let's do it. X is equaling to negative b plus or minus square root of b squared minus 4ac divided by 2a. Right. We all know that a is a coefficient of x squared, b is a coefficient of x, and c is the constant. So we just have to substitute them. So let's substitute. We know that x is equal to negative b. Our b here is going to be 2 plus or minus the square root of 2 squared minus 4. A is 1, and then our c is also 2. There we go. Divide by 2, and then our a is 1. If we continue here, we know that this is going to give us x is equal to negative 2 plus or minus. Inside the square root here, we're going to have negative 4 over 2. Guys, for the fact that we have negative inside the square root, this will change into the imaginary number. Remember, imaginary number is equal to negative root 1. Just in case you don't know, I've made a video explaining this. You can go to the description, click on the video where I explain this, and the very same video will pop up on the top right of this one to understand this one better. So we can rewrite this like the following: as a negative 2 plus or minus, we can say the square root of 4 multiplied by the square root of negative 1. All this is divided by 2. So we can continue here. We say negative 2 plus or minus. What is the square root of 4? We know that it's going to be 2. But what is the square root of negative 1? We say it's an imaginary number. All this is divided by 2. So we can say x is equal to negative 2. When we have plus, we're going to have plus 2i divided by 2. Or x is equal to negative 2. This time around, we're going to include negative 2i. All this is divided by 2. So if we continue, we go further, we know that these two divide these two terms here on the numerator. So we're going to have negative 1 plus I, or x is equal to negative 1 minus I. Guys, this is how you solve this one here. Remember, if you use a calculator, it's going to give you an error here. This basically means that you must not use a calculator here. Rather do it manually so that you can have negative 4 under the square root there. If you use a calculator, it's going to give you an error. So the trick here was for you to able to identify that this is actually complex numbers. All right, guys, I hope you managed to understand how to solve this one. It really was not that difficult. If it so happened that you didn't understand, go to the point where you didn't understand, rewatch at that point, and if that doesn't help, do not forget to leave a comment on the comment section. I'll try to answer you to my level best. But then if this part of the video helps you to understand, do not forget to like, share, and also subscribe to the channel if you haven't subscribed. You can also support the channel to grow by clicking the super like button. That will help us and help the channel to grow and become better. All right, guys, we are done with question 2.5, and also we are done with question 2 as a whole. I hope this helped you to understand. At the end of this video, there will be a playlist with all the questions from these question papers, and also a full question will be there on that playlist. Thank you very much, guys, for watching. Till next time, cheers.